Today's seminar is going to focus on writing linear equations in slope-intercept form, and our goal or I can statement for this lesson will be I can write linear equations in slope-intercept form given different scenarios. So go ahead at this time, pause the video, write the title in your notebook as well as the goal. The foldable that you should have if you're a part of the seminar should look like this. And what we're going to look at today is writing linear equations in slope-intercept form when we're given different types of situations. So one possibility would be given the slope and y-intercept, given a graph, given a point and the slope, and given 2 points that the line passes through. So we aren't always going from a graph directly. We can be given different pieces of information in relation to a line, and with that information we are able to write it in slope-intercept form. The examples I am going to do, when you flip this open, I will do example 1, 3, 5, and 7, and then I'm going to have you try 2, 4, 6, and 8 on your own after I explain through 1, 3, 5, and 7. And please do try example 2, 4, 6, and 8 before going back to your exit slip so that you have a good understanding of exactly how to work with these different types of situations. So let's go ahead and start with example 1. And the first thing we're looking at is writing linear equations in slope-intercept form when we're given the slope and the y-intercept. Just zoom in here real quick. Alright, so what it tells us here is write an equation of the line with a slope of 3 and a y-intercept of -2. Now, at this point, you should probably know what slope-intercept form is, or the general form of it. Remember, that's y equals mx plus b. So using what we're given in this statement here, we'll have to fill in the different pieces that we're given. So if you recall here, m is going to be your slope, and b is your y-intercept. So basically all we need to do here is whichever numbers we're given, we need to plug them into their correct spaces. So I know that my slope in this case is 3, so we'll say m equals 3. And we know the y-intercept, and we represent that with b, and we know that is -2 here. So I'm going to fill those in within my equation. So I know I'll always have y, I know I'll always have an equal sign. So I need to replace m with 3 because that's my slope, so the slope is 3. X will always be there because these will be like input and output points that you would get or possibly plug in. Now, at the end here it says plus b, but if we're given b as a -2, then we can just say -2. You could say plus -2, but -2 and plus -2 are the same thing, so I'm just going to write -2. This is as challenging as this type of problem gets. If you're given the slope and the y-intercept, all you need to do is plug in those two numbers that you're given, and you're good to go with that example. And then let's move over to example 3 here. And we're going to write this equation in slope-intercept form. And we're given a graph. This we've been doing throughout the past couple lessons, especially when we first started working with slope-intercept form. We were writing the equation from a graph, and we were also looking at the graph and deciding what the slope was and what the y-intercept was. So that's exactly what we'll be doing on this one. So remember, we're still working with y equals mx plus b. Now we need to figure out what the slope is, and we need to figure out what our y-intercept is. What I would find first is my slope. So I'm going to start at the leftmost point that I'm given, which is this one here, and I'm going to see how far I need to move up or down and how far to the right sometimes left, I need to move. So in this case, it looks like I need to move up, and I need to move up 1, 2, 3, 4 spaces. So up 4, and to the right 2. So my slope, which I'll just write as m, equals 4 over 2. Now we need to think, is this completely reduced? No, this isn't completely reduced. We can divide 2 out of both the numerator and the denominator, so I would get 2 over 1, or just 2. So we figured out our slope, and let's just make sure that that 2 over 1 works, that I'll end up at a point on the line again. So if I go up 2, 1, 2, and to the right 1, because that's moving in the positive direction, to the right 1, I end up back on the line. You can see that that point would be right here. So we figured out the slope. Let's figure out what the y-intercept is. So remember, that's b, and it's the point at which the line is touching the y-intercept. So it looks like to me that it's at -1. So since it's at -1, we can think of that as a coordinate as well, and y-intercepts will always take the coordinate of 0, -1. We don't, or I should say your x value will always be 0, and then whatever your y value is, that will be your y-intercept. Just to clarify, it's not always -1. I don't necessarily need the coordinate at this point, but it's good to know that that's how the y-intercept is represented. So I'm given all the pieces here I need now. Let's fill in the spots in the slope-intercept equation. So I'll do this up here since I ran out of space. Y equals, slope was 2 over 1, or we could just write 2. I guess for now I'll write 2 over 1. Either way is fine. If I write it over 1, it reminds myself that I need to move to the right 1. X is always there, and b is -1. So we would just write -1. And that would be our equation for this example and looking from a graph. So the steps here include finding the slope using the 2 points that you're given on the graph, and then identifying your y-intercept and filling in those pieces or substituting those numbers in to the equation and writing it. So that one was given a graph. Okay, so the next couple of examples are where it's going to get a little bit trickier. So this one, we will be given a point and the slope. Now there's going to be 2 different ways you can do this, and I'll show you both ways. And I'm going to actually do this one on a bigger piece of paper since I'm going to need a little bit more room. So what it says is write an equation of the line that passes through the point 6, 3 and has a slope of 2. So I'm just going to take the foldable out now and get my other paper. Zoom out a bit here. Okay, so again, it says, example 5, write an equation of the line that passes through 6, 3 and has a slope of 2. So the first equation we're going to use is point slope form. Now this does come up in ALEKS, so you will need to know this. I would say that using this method will get you to slope-intercept a lot quicker than the second method that we'll use, but it's personal preference and you can use whichever one you want. So my equation for this is y minus y1 equals m, which is your slope, times x minus x1. Now the points that we're going to fill in are going to be 3 points in here. y1 will be filled in, m will be filled in, and x1 will be filled in. So if we look at this point 6, 3 up here, we know that that's an xy coordinate, or it's a coordinate that's in the form of xy, because that's how we write them. We're going to fill in our x value where x1 is, and we're going to fill in our y value where y1 is, and our slope is going to be m. So let's go ahead and do that. So y minus 3 equals, slope is 2, So we're replacing these. We're substituting in would be the correct mathematical language to use. Times x minus 6. So a couple of things are going to come back into play here. One will be solving equations for a variable. In this case, we'll be solving for y because slope-intercept form is y equals. And we'll need to use the distributive property here as well in order to take care of this 2 times the quantity x minus 6. So I'm going to write down what stays. The left side y minus 3 will stay, equals. Now let's distribute here. Now remember, you can draw those arrows in like we did way back when. Remember, there's an invisible 1 in front of this x, so it's 2 times 1. The coefficient there on this x is 1. So that would give us 2x. And then we'd have to do 2 times a negative 6. Remember, we take the sign that's with this number here. 2 times negative 6 would be negative 12. Now in this case, we're almost there. We're almost to slope-intercept form. The last thing we're going to need to do is get y by itself. And I see y is over here on my left-hand side of my equation, so that means I'm going to have to get rid of this 3 in order to get y by itself. Currently this is a negative 3, and I'm going to have to cancel that out or eliminate it. So I would have to add 3 to both sides. And this 3 is going to have to get added to 12. This negative 12 because, remember, combining like terms. So all of this stuff is kind of coming back that we've used in the past. And so let's go ahead and take care of this then. So negative 3 and 3 will cancel. Those would form 0. So I'd have y equals 2x is still there. And here's integer operations again. Negative 12 plus 3 would give me a negative 9. So this is one way that we can go about using a point and the slope in order to find slope-intercept form. Let's go ahead and take a look at the second method that we can use, and that is by using slope-intercept form. So let's recall that our slope was 2, and our point that we were given was 6, 3. Now using slope-intercept form, we should still get the equation y equals 2x minus 9. We'll just have to fill in different parts here. So in this case, let's fill in what we know. Well, we know our slope, and we know that this point 6, 3 is a coordinate, again, that's made up of an x point and a y point. Now let's look at what we know here in our equation. So we know what slope is, we'll be able to fill that in, and we know what our x and y values are that we need, so we'll be able to fill those in, and we'll just have to solve for the y-intercept. So again, like I said, knowing how to solve equations is going to be important here. So let's go ahead and fill in what we know. So we know that our y value is 3. We know that our slope is 2. We know that our x value is 6. Now remember, a number or a variable, a number next to a variable, in this case to be 2 times x, but also a variable next to a variable is multiplication. So we're going to have 2 times 6. And then I'm going to have my plus b here, but I don't know what that is. That's the variable that we need to solve for. That's our only unknown in this case. So let's go ahead and take care of what we need to here. So 3 is going to stay. 2 times 6 is 12. And then plus b. Our goal here is to get b by itself so that we know what that value is and we can plug it in. So if I subtract 12 from both sides, because this is a positive 12, we want to subtract in order to eliminate it here. That eliminates. 3 minus 12 is going to be negative 9, and that's going to be b. We're not quite done though, because we're going to have to go back and write this in slope-intercept form. But now I have all the pieces I need. I know what my m is, I know what my b is. Our x and y now aren't going to be as important because they just helped us solve what our y-intercept is. So we just need to plug in the pieces that we need. So we'll still have y equals, slope we know was 2. Our x value will be whatever that would be, whatever we want to put in. And then we want plus, or I should have said, I guess, -9, -9. But this works as well. I'll rewrite that in another way that we've been used to. Y equals 2x, and then we can just say -9. But plus -9 is just fine. So as we can see, these two different methods of solving gave us the same equation. Use whichever one you prefer, unless otherwise specified on an assignment or something like that. I much prefer using point-slope form. I think it's a little bit quicker than using slope-intercept form. But like I said, both work. So that's example 5. Make sure you get that copied down on your sheet. And then let's take a look at our last example before I have you guys, or all of you I should say, work on the 4 extra problems that I have remaining here. So last but not least, there's one other example that we have, and that is writing linear equations in slope-intercept form when given 2 points that the line passes through. So this is going to be a little bit similar to using the slope-intercept form method of solving example 5, and also, well, you could really use both ways, I guess, but I'll show you using the slope-intercept way here. First and foremost, we're going to have to go back to something that we were using a couple weeks ago, and that's finding the slope given 2 points. Because in order to write in slope-intercept form, we need to know what that is. So if you recall, that's m equals y2 minus y1 over x2 minus x1. So let's go ahead and fill in what we know and solve for this. So m equals, y2 is 13, and if you want to label these, you can as well. So x1, y1, 0, 4 would be x1, y1, 6, 13 would be x2, y2. So y2 is 13 minus y1 is 4, and then x2 is 6, and x1 is 0. 13 minus 4 would be 9. 6 minus 0 is 6. We want to reduce that as much as possible. So 9 over 3 would end up being, or 9 over 6 would be, so I divide 3 out of each, so 3 over 2. So now we know our slope. So since we know our slope, now let's go ahead and use the slope-intercept form in order to use what we know in order to solve it. So y equals mx plus b. Let's remember that. So let's fill in what we know. And you can use either of these points and you should get the same equation. So let's use 0, 4. I like that better. I feel like it's going to be easier to work with than 6, 13. So we're going to fill in the parts that we know, like we did up here. So I'm using 0, 4 as the point that I want to plug in for my x and y values. That means I'd have to put 4 first. 4 equals, my slope I know now as 3 over 2. My x value is 0, and remember those will be multiplied. And then I will have plus b because that's what I need to solve for. So this should be pretty quick and painless. So 3 halves times 0 is 0. 4 plus b. 0 is, we can't really add or subtract it, so it's gone. So we know that 4 equals b. So now we have all the pieces that we need in order to solve this, in order to write it in slope-intercept form. I know my slope, and I know my y-intercept. All is the matter of, the only thing that we need to do, is to put in, or substitute the values we have for our slope and our y-intercept. So that should be y equals 3 over 2 times x And then, since it's a positive 4, we'd have plus 4. Now what I'd like you to try is using the 0.613, plugging it in like we did down here, and see if you get the same thing. And chances are, well, I know that they are 100% that you'll get the same thing. It might also help to use the point slope form that I talked about, and you can also do the same thing by using that to solve this equation, and you should get the same answer there as well. So give those a shot. So I showed you a couple examples here. Remember, we did slope and y-intercept. We did using a graph to write in slope-intercept form. We did given a point and the slope, and we did that on a separate sheet of paper. And then we did given 2 points that the line passes through. And you can use several methods to solve here. Use whichever one that you're comfortable with. I'd like you now to try examples 2, 4, 6, and 8. And I'm going to give you the answers to these just so that you can verify. The first answer that you should get is y equals negative 1/4 x plus 5. Your second answer you should get is y equals negative 4 x plus 1. The answer you should get here, and I want you to try both methods here, okay, the point slope form as well as the slope intercept form for finding that, but the answer you should get is y equals negative 3/4 x plus 2. And this last one here is a little bit funky. It's in function notation, which is something that you'll see next year. But all this is telling me is when I do my input of 6, I get my output of 4. So that would be the coordinate 6, negative 4. And this one here, it says when I put 9 into whatever my function is, I get negative 9 out. So that would just give me the point 9, negative 9. Remember, your input is x, your output is y, so those just match up there. Try the slope-intercept form here as well as the point slope form. I will be coming around to check your work on these to see that you did them. And once you complete all 4 of these and your answers match up and it makes sense, then go back to your exit slip and make the corrections there. So today we looked at, like I said, writing linear equations in slope-intercept form. Let me zoom out. And when we're given slope and y-intercept, given a graph, given a point in the slope, and given 2 points that pass through the line. These are all topics that you will encounter in ALEKS, so it will be important that you understand how to work with them and how to work with these different types of situations. So just as a quick review then, like I just said, writing linear equations in slope-intercept form is what we looked at today. Our goal, or I can statement for the day was, I can write linear equations in slope-intercept form given different scenarios. If you have any questions, please ask me. If you're not quite sure how to do some of these, you can absolutely watch the video again. And like always, I'm available.